Okay, hello everyone. We are looking at Wolfram Language Design Review, part of our incremental language development series, and we have a variety of topics today from index functions.
So we have Ed here. There's kind of a collection of function repository functions that deal with getting the index of things like tuples or going from tuples to an index value.
Given a canonical ordering, which element of the canonical ordering is this?
Right. And there's a whole kind of class of these, and they are reasonably popular in function repository. Yeah. And so my general thought was, is there some way to generalize this to a index function or indexing?
Okay, here's a question. How does this relate to lazy computation? Because
one is a subset of the other. Like, not everything can be indexed.
For sure. Right. But, okay. So, I mean, basically what you're suggesting is some kind of language construct where we're saying, let's say we have this, and we have, comma 20, let's say. And then we want to get, that is the base object. Am I making sense? My question is, what is the nth thing in that base object?
Yes.
Right.
And it's an interesting, so in some sense, well, let's say that this was called something like, well, in some sense, what we're looking for is that, right? It's the don't evaluate
the reverse.
Or compute that part. Or the other thing is position in this of, oops, that's annoying, of, whatever it is, whatever. Okay, so those are the two.
Sorry, one comment. It's not obvious that lexicographic order is always the best one for indexing.
I see what you're saying.
I think it is with these 5, though.
But there might be some where lex order is not ideal.
Right. So in a sense, the more complete form would be a sort into favorite order somehow. I mean, that's the thing we're trying to represent. All right.
Yep.
Yes. Yes.
Now, some of these functions probably have various options. What's an ordered tuple? What do you mean by that? Is that different from tuples?
Yes, it's basically a tuples with sort applied.
With sort applied to individual tuples, and then
any union.
Okay, but so do we not have a top level function that generates that list?
I don't think we do, but the code's really short.
Well, I understand that, but I'm asking, is this a useful thing to have?
I use it quite frequently.
So, I mean, this is basically a, sorted tuples or something of 0, 1, 2, comma, What's that thing there? What does that mean?
Tuples of length
Tuples
3.
of 3 elements, yes.
Why isn't it just comma 3?
Because you can give a range.
Because then you,
Sorry, yeah. I assume it's the same as normal tuples. Yeah.
Sorry, I'm confused. Normal tuples is
Oh.
not documenting. Oh, it's just, I see. It's just a one element version of what would otherwise be a multi-element. By the way, we should probably promote this case to the top here. I mean, I certainly use it with some frequency.
Okay, got it.
Okay, in any case. I see. Okay. All right. So the other thing is to have a function that generates this nice and efficiently, right? What would you call it? I mean, is sorted tuples the right name, guys?
that's good. Ordered tuples.
Why would we ordered tuples? What does it mean, ordered tuples?
It's the same as sorted.
Okay, but is that obvious enough what that means to that it isn't just it's sorting the outer list? I mean, it's the or is it distinct tuples or something? But that might mean something different as well. Set tuples, that sounds wrong. Anybody?
I tend to prefer sorted tuples. We don't have a lot of, I think we have sorted entity class is the only sorted head we have in the language right now.
Okay, what does, okay, let's pick on some people. Ed, Christopher, Brad, opinions.
It'd probably be best to look at the literature.
Well, take a look. I mean,
I think sorted tuples would probably win out though, because it's so easy, it's so obvious from a Mathematica standpoint what that would mean.
fine. All right, okay, so first point is we got a new function, sorted tuples. Does that make sense to people?
Yep.
And okay, then the next thing is how do we do this? Right? Let's see. Well, let's have some ideas here. Come on. Do I really have to be the one saying everything here? Brad, Christopher, somebody, Ian, Rick. Ideas.
For all of these combinatorial items that would support indexing, that could be an option to what's already in Mathematica.
What are you talking about? What do you mean? I don't understand.
For example, with tuples, if you had like a indexing option,
No,
then it would.
that couldn't work because, I mean, for ordering it could work, but we can't return one thing returns one tuple and the other return no. All right.
So there are some functions like subsets, for example, where I think there's a usage that you can effectively use to get this subset with index whatever. Yeah, the last usage.
Right.
So I mean, right. I mean, that would cover the from index cases if we had stuff like that in all these functions, which I'm not sure we can, but
well,
yeah.
let's see if we can. I mean, so let's take tuples as an example, right? So, okay, so subsets, you're saying that we can perfectly well say, so this is the case where we have a list and we say, what's the end spec?
It's how big the subset is.
Okay, so let's say all, comma, and then let's say here, the 1000th subset. Cool. And that's a take spec, which is kind of nice. Don't you think?
Yeah, I
Mhm.
mean, the only thing that's slightly annoying is the fact that it comes back in a list, but whatever.
Yes. I think that's probably livable with, because the value of having a take spec is probably exceeds that.
But one sometimes wants to reverse.
I know. So let's think about that.
Right. That seems like it kind of has to be a different function because it's just the, its fundamental arguments are just totally different. I mean, unless we just said subsets of an integer assumes it's an index. No, that doesn't even work because you need to, yeah.
Right. So then this will be, okay, so let's just try something here. Find index. This is perhaps crazy. Okay. This might be crazy, but I mean, this is saying, do we have any function that works this way?
I mean, it's sort of like first
Solve.
position of range.
Kind of like find instance, right?
It is, yes.
You'd have trouble if like the first item was permutations of range 20,
Why?
because 20 factorial is a big number.
No,
It
no,
would
it's a
gen-
pure
it-
function, it would never evaluate.
I see.
But it's a strange syntax.
Yeah, I mean, wait, are you proposing this as another function that might be useful? Or are you proposing this
No,
as the way that you
I'm-
expose the subset index?
That's what I'm suggesting. I'm suggesting that the subset index is like solving an equation. I'm suggesting that we try to look at, indexing, let's look at the other functions, see whether they could have something like subsets added to them.
I just think it seems like the level of magic is quite high. And unless we're going to have some whole sort of solving apparatus where you can have some kind of nested situation where there's an algebra of it, it doesn't seem like there's much point.
Like, and you have to evaluate the range. Sometimes you don't have to evaluate the first argument. So,
All right. Okay, but the alternative here would be to have something where, I mean, how do you generate? You have to have something that says what the universe is that you're looking at, like subsets of range of 10, all.
I mean, you have to give it all the arguments that you'd give to subset, and then you
Right.
give it the index.
the,
And then
the
give it-
element.
The element.
Right.
From index to index could have a list of supported functions, combinatorial functions.
But again, the weird thing is you have to give the arguments for those functions too. You can't just say from index of subsets. You have to say from index of, and then give it the whole subset spec.
See, this is proved rather nice, where you can have that cellular automaton disembodied on its own, and then an operator form here.
Right. I mean, this is the lazy version of things, would be subsets returns unevaluated, but you can map over it and you can fold over it and whatever. And then
Yeah.
of course you could symbolically ask it what the position of some index is, but obviously that's not how subsets works.
Except that in the things we've been talking about, we have a concept of lazy subsets, right? And that's what we're talking about for the lazy stuff, correct?
I think there's a lazy subsets, yeah.
Right, but so in particular, if we did this, maybe we solve both problems by just going through the laziness business. Right, because we have essentially an unevaluated subsets by setting it up as lazy. Is there somebody here who knows where we got to with the lazy design? Avery, do you know?
I don't, but I can ask.
Well, but who's dealing with that?
I'm not sure. I think it was Kristen in the past.
No. But we've had much more recent meetings about it.
Yeah.
We've had a meeting within the last few weeks. So who was PMing that? Let's see.
There's a Packlet on the Packlet repository. Is that related?
Yeah, presumably. This lazy list function, this file was from 2014. Where is our more recent stuff here?
I'm checking right now.
I'm essentially certain that the right way to do this is using this lazy stuff. Because that's going to have, we were talking about, Christopher, do you remember you were in that meeting?
I've been in several of the lazy meetings. Yeah.
Where do we think, what do we think that the, what is the category?
Right.
Oh, it's in the is it in the multi-computation?
It was, yeah.
Oh, so that might be in a different area. Hold on.
I think it was for a long time in there, but now I thought that like Roman and Leonid were doing things related to that. And I'm not sure that's under the multi-computation stuff.
Okay. I don't even know where it is.
But
okay.
I mean, I think I know roughly. I mean, I think basically the stuff there is that there's there'd be a generic kind of lazy list generator kind of object. And you can make one that generates subsets. And I think, I mean, I don't know, right? There's some versions of that where you generate this, you make this generator thing, but you sort of don't really remember how you generated it or what generated it. So you might have this generator, which is sort of a big block of code, but you don't necessarily know it came from a call to subsets, in which case it would be hard to then do this. But I think most of the versions that at least like Leonid and Roman were looking at do know that like, oh, this generator, whatever you want to call it, comes from a call to subsets. And so, you can.
Yeah, my recollection is that we have a generic function lazy list. And that there is a generator and that, that there are a few certain functions for which there are lazy versions which can act as generators, of which subsets is an example.
Right,
and
I mean,
then
basically any of the constructors can have lazy variants.
Right, and all 5 of these would count as that, but you do need the underlying algorithm.
Sure.
For example, permutations requires Lamer codes.
We understand that there needs to be an algorithm. It's not just generic. But I think that's the right design, is to go through the lazy system and probably also, I mean, going this way round, it seems to me that adding an argument to tuples, which is a take spec, seems worthwhile to me. Does that make sense? I mean, so then you mean subsets, right? Here. And then permutations. Let's take a look at permutations, whether that has.
You might also want to look in the details of tuples, because some of these functions have undocumented, or like they don't have a usage line for their n argument form.
Okay. Seems to be clean.
Okay. Yeah.
Okay. So that seems worthwhile. I mean, Ed's algorithm just seems like a worthwhile thing to put into tuples. It doesn't seem any harm. Make it consistent with subsets.
Right, not my algorithm though. I stole everything.
Okay, fine.
They're all well known.
That looks clean as well. Looks good. We should add it in there. Now, what's standard order?
That deals with bell numbers. We did those 3 years ago.
Well, that's a different function. Okay, so this is, okay, hold on. Let's just summarize what we're talking about here. Okay, so we've got one function, which is, so let's summarize our new functions. Go ahead, Michael.
There's one more that we need, which is probably the second most important, I think, is integer partitions.
Yes, I agree. Okay, so hold on. Sorted tuples. That's a function, right? Now let's look at integer partitions. Oh boy. Oh, I see. Well, we've got here n partitions. So then all we have to do is make that a take spec. Okay. So this case would need to be generalized to a take spec. That makes sense.
So are you sure those are actually take specs where you can give like a span, for example?
I'm not sure, but it will be good if they were. Okay, so then all right, here we have adding a take spec argument. And so that would be added to tuples, 1, 0, 20, comma, and then this would be, I think this is a nice way to do it, actually. I really do. I think this is a perfectly reasonable way to do this for this way round, which is, I think, the more important way round.
I agree. With one corresponding count function.
What does that mean? Oh, I see.
I want to go over all this 10 to the 12, which I succeed in 4 days, but I need to know how far my index goes.
Well, that's interesting because that's a separate thing. Okay, so wait a minute. Subsidiary functions. How big can the index be? And then which index does this element correspond to?
By the way, just in terms of how big can this index be, that's also something that would be useful for like cellular automata.
Indeed, indeed. I keep on getting bitten by that.
Also, our error messages have improved quite a bit in the past recent versions, where if you put in something too large, it will basically return that it's too big.
I know.
I mean,
Right,
theoretically, there are two
Go ahead.
more, next and previous, because sometimes while you can do from index to index, it is computationally prohibitive to do it, but you can immediately go from one to the next.
Right. I know. I mean, again, that seems to me to be something which, that needs to be part of the lazy system.
Right. There might even be a general, general stuff in the lazy system for asking at least for the next one.
Right. How big can the index be? Obviously, is easier in the lazy system. It's just length.
Well, no, it's very hard. I mean, in general length, you can't answer length because it might be infinite.
No, I understand that. I mean, hard to compute, but actually in the cellular automaton case, the annoying thing there is, if there's a rule number, let's say something like this, how big can Rn be? So it's not really the length of anything.
No, I know it's not. But I think it's a related thing where I think there might even be like an error message where if you give it something too big, it'll just tell you, here's the number.
Yeah, I know.
And so, in the past, I've done things where I'm just like, oh, well, I put in some astronomical number and then I look at what it spits out max is.
Yeah, right.
I'm also guilty of doing that one.
Yeah.
That's wrong. We should just give a message in this case. Right, because if I actually give a concrete thing here, I'm fairly certain it will give an error. Yeah, we should change this. Brad, I think you might be about to be the keeper of this function.
Well, we had actually talked about this rule issue in a previous meeting, and I'm not sure where it got written down.
Okay, well, Avery, maybe that's for you to go chase, because I think this, I think you should just generate an error message in this case.
And is that going to be a good enough solution as opposed to creating a whole new function that tells you what the
a
maximum
great
is?
solution, but it's a minimal solution. It's at least we get that.
Yeah.
Right.
Yeah. Okay.
Right,
I mean,
separately, there should also be a whole new function that tells you what the max rule number is.
right, but I think what we really had, we had a specification, but it never got implemented, called rule space data. Although what you're suggesting here is that that's a more general function, but the problem is without a lazy version, you know, I just don't know how we get this and this thing, like how many tuples, you know, tuples 1, 0, 20, you know, how long is that list? That seems like a kind of a separate problem. See what I'm saying? From the cellular automaton case.
They're not that different, I don't think.
No, but they're, in terms of language design, they're different. Because this one, you've got a concrete thing. What you're trying to do in this case is you're trying to compute, you know, whatever it is. You're trying to compute as if you're trying to compute this, right? Really, you're trying to compute that, right? You don't want to actually write that, but that's what you're trying to compute. See what I'm saying? Whereas in the other case, there's nothing to write down that you're trying to compute, is there? So I'm saying, I mean, if we had a function called cellular automaton rules, I don't know what it would even do, you know, and it just gives a list of rules, right? Then it would be again a length thing, but otherwise
Yeah,
we
well,
just don't know.
that's kind of what rule plot is supposed to do, right?
No, it isn't. No, I mean, no, I'm saying a list of possible rules. Like for the elementary cellular automata, it would just be numbers from 0 to 255.
Right. Although that list could be very, very large.
Indeed.
And
right.
and if you're giving rule numbers, it's going to be
It's
very
totally
boring.
uninteresting. Right. So, but the problem is we're trying to solve the problem of how big can Rn be in this case.
It is already a solved problem, isn't it? I mean, maybe not for every possible
Oh
specification.
yeah, I mean the code has this information in it. The question is, how do you get it other than by generating an error message? See what I'm saying? That's the question. Now, we also have these forms of cellular automaton that are based on association. And maybe in that case, we can, I mean, again, for cellular automata and Turing machines and so on, I kind of like this rule space data idea, which could be a Brad function. I think this is a separate problem. Okay, let's just review where we're at here. We've got one definite thing, which is to put in these index algorithms as the selectors in tuples and these other functions. Agreed? Anybody got
Yes.
a, okay? Okay, then we've got, my opinion is that all this other stuff should go into the lazy business. Because I think it's, you know, it's total mess to be introducing functions to do these rather obscure cases. So, and you know, this will also be accessible from the lazy system, but I think it's convenient to have it accessible here. Does this make sense to everybody? And I'm going, oh, you had said one more thing, Ed. Okay, we got sorted tuples as a new function, new enumerative function. Now you're saying the standard order index, you are proposing that as another standard.
It was this was very useful for your
remember.
project, but I don't know whether they're used enough that we should bring them in.
Well, what are they?
Open up the details and options. It's somewhat complicated. It's sort of like a combinatorial greedy function.
I mean, I remember why I needed these, but that's, I mean,
This could just stay as a WFR.
but does it have a name? Standard order index is not going to be a name that's going to survive. Be more descriptive. What is it?
There's standard. Let's see. It's something. It would have to be something dealing with standard order.
What is standard?
I think there's a integer list in the front missing.
What do you mean?
Integer list standard order, I think, would be the clear name there. Given the integer list, give me the index of its standard order.
What is an integer list? I mean, you mean
3497. The integer list is a list of integers.
okay, but this applies to any list, right? Any, if I had 100 in there, I would get a standard order index for it. Right? It's like Gödel numbering of some kind. It goes on forever. It's not just like, you know, get me the position at the index of this in the permutations. It's like, given any integer list, what is its index?
Correct.
No, it only works
No?
for lists that are already in standard order.
No, yeah, that was
Starting
not
with-
Stephen's questions. Yeah.
Okay.
What? Wait, what is standard order?
Starts with 1, contains 1 through n basically, and there's particular rules so that
Yeah, is it sorted? This sounds way too specific.
it's very specific.
Okay, then let's not worry about it. Then it's
Okay.
a good place right now.
But somebody else in this family that is of relevance would be the rationalist itself.
Explain.
Like for the classic Cantor-like proofs, I would like to know 419 over 517. What is its number if I would sort the rationals?
Right.
So position
What's that?
a take thing for fairy sequence.
Yeah, that's what that would be. I mean, we don't have much for the fairy sequence right now,
Correct.
and we probably should. Because I agree, it's a common thing. Do we have WFRs for the fairy sequence? What is wrong here? Why is this not working? Oh, come on, what's this doing?
Ooh, it is a built-in function.
What is?
A fairy sequence.
What does that one do? What does it do for?
It gives you all those ones with a maximal denominator.
So why isn't it? Oh, I see. It's excluding the ones which reduce.
Oh, there already is a take element.
In this particular case, there is.
Yeah, here the problem is not so much the syntax, but it first makes the sequence and takes it out, so it doesn't work for large numbers.
This thing here. So it's an
Yeah.
algorithm problem.
Yeah.
Well, that's a question for Ed, whether that's solvable.
Okay.
Yeah, I would have thought there was an algorithm for that.
Yes. Sternbrocco, I think it's called.
Oh, yeah. I know those things. Sternbrocco trees or something.
Yeah.
Well, that seems like that's a very Brad-like algorithm too. All right, sounds like that's a thing to do here, is to make this more efficient. Okay, should we move on from this item? Yes.
Sounds good to
guys
me.
are very silent today.
We have a few people missing.
And deep thinkers.
I
left
was
here.
late because my previous meeting ran long, but I'll try to be more vocal now.
Okay. Generally, you don't have too much trouble with that. It's okay. N-body simulation. But we don't have Rob Knapp here, right?
That's right. I asked to see if he was available and didn't get a response. We could bring this up later if you want to move on to other topics.
Well, let me explain something that I was realizing. Right. This is the algorithm. What do we use for the current hard sphere gas thing? Do we use the order log n algorithm or not?
No, not to the best of my knowledge.
I had no idea that Etienne had worked on this.
Even the hard square code that I wrote probably doesn't use the order log n, because you have to do some smart queue management or something to get the fastest possible code.
I had completely forgotten, or maybe never knew, that Etienne worked on this. Maybe you could, Brad, just. Why am I using Safari here? What is it doing? My God. Let's see. I'm just going to send this. I had no recollection that this was a. Okay. In any case, the thing that I was thinking about, my gosh, where did this come from? Where did all this material come from?
Michael pulled together a lot of the references.
I see.
There's many
there
more
was-
than that, but yeah.
There were many more.
Yeah, this was just
Yeah.
kind of a subsampling of different considerations that go into handling hard body problems.
I mean, there's no question that the Newtonian event chain is the method of choice for hard spheres.
Okay, that's interesting. So that's an event.
Yeah, and I
That's-
think that barring this issue of the possibility that, you know, as many spheres as you want can collide, or circles can collide at exactly the same time, then the Newtonian event chain thing is something that people have already figured out how to do pretty well.
Okay.
But
So-
then, you know, most of the people who are doing this are not looking at the question of, you know, exact generation of randomness. So they never cared about the multi-collision thing.
I understand. I understand. Boy, this thing I've certainly written about at length, but probably nobody's ever bothered to read it.
If I might recommend, physics engines have gotten big in gaming. It'd be good to grab whatever's free and incorporate some of that.
Yeah,
Wasn't
but
there a
do you
long-running
think that the
project named
physics game
Physics?
engines, do we think the physics game engines use the event chains?
No.
No,
definitely
I
not.
don't think so either.
And in fact, some of them are quite approximate and like, you know, do
Yeah,
weird fake
'cause
stuff
that's what-
because, you know,
It's just a
it's
game.
right. But there was some project for a while of making some connection to PhysX, which is NVIDIA's
Yes, I know. I know.
physics
I don't know what's
simulation thing,
happened.
but yeah.
I mean, the whole virtually any paper that deals with hard spheres, as Etienne correctly pointed out, does some kind of thermodynamics. So you generate large ensembles of trajectories, then derive your thermodynamic averages or maybe correlation function, then do some backward analysis that your numerics is good enough, because every single trajectory will be totally wrong.
Yeah, I understand. I understand. So that's solving a different science problem from the one. Okay, look, here's my point of view here. That to me, the hard sphere gas is a minimal version of an agent-based model in some sense. And the way I was thinking about it is, to what extent is it true that what matters in the agent-based model is essentially the causal graph of which agent interacts with which agent, which in the case of hard sphere gas is determined sort of geometrically.
Yeah.
But I mean, we've tried to make a design for general agent-based modeling. And I mean, Christopher, you and I have looked at this several times. Does anybody know where that material is by any chance? Anybody?
There's one more problem that people solve, or two more. One is basically purely mathematical, showing that the limit of certain hard sphere things goes to a Boltzmann equation, but this is all very mathematical physicsy. And the other one is, given a locally confined cluster with initial velocities, what's the maximal number of collisions that can happen?
That's an amusing question. I mean, yeah.
If they expand to infinity, yeah, so they can fly away.
Yeah, I understand. It's kind of like, how long can it rattle around?
Yes, exactly.
And is the answer to that known?
There are bounds, yes. There are known upper bounds.
How big are they?
Oh, big.
Exponential?
I don't remember.
Multi-exponential?
I didn't read so carefully the papers.
Right. Okay. Where is our stuff? Where is our design for agent-based? Anybody know?
I'm not sure it was ever particularly far along.
No, but there is some stuff that was written down.
I think there was a dedicated meeting for it once.
Yes, there was. And I think the only question is, where is it in, let me just look here. Well, there's some random notes here. Okay. I don't know where these are, but we have some random notes. SW notes modeling. Okay, so
I got that.
this was the idea of just general models. Okay. The heck is this? Right. Okay. So that didn't get very far there. Okay. So my basic claim is, what matters is, I mean, is that true for general agent-based models? I mean, generally you don't think about like a self-gravitating gas as, that's an n-body simulation, but it's not an agent-based model. Usually agent-based models have discrete events. Is that a fair statement?
I think so.
Maybe. I mean, I would say that it should count as an agent-based model, but in practice, people doing agent-based models are much less precise, and they don't usually. Yeah, they usually right. I mean, they usually
there are
do like continuous
that allow
time and stuff like that.
a permanently long-range interaction with other agents.
Ian, what is this thing you just sent through for the? What does this have to do with? I'm sorry. What is this about? Is this about the fairy sequence that you sent through?
That's the Stern-Brokat tree. That was from a while ago.
Okay, so you're saying that will. What should I run this?
Yeah.
Okay. Do we have a function in the function repository for making Stern-Brokat trees?
Yes, FUSC, F-U-S-C.
In the function repository?
Yes.
Why the heck is it called that?
It's because it looks like obfuscated code. but it's famous for being called Fusk.
Wait a minute. You're saying our function repository has a function called Fusk in it. Is that what you're saying?
Yes. And the neat examples it shows how you can generate that tree.
Okay, but that's not the relevant thing here. That's not the relevant thing. We're not interested in that. We're interested in a function where you know that you want to generate that tree and you have a function that generates that tree, right? We're not interested in it being in the neat examples of some other function. Am I making sense? I mean, that's what I was asking. Do we have a function that generates where you say, Stern Brocott tree or something, however it's spelt, and it generates that? Yeah, is the answer to that yes or no?
Yes, we have that too.
So in the function repository, we have a function. Let me look it up. Really? We have that function.
Let me see.
I don't think so.
It seems to just be a numerical function, so it gives you a sequence, not a tree.
What is going on here? Why is that search? Look at this. What the heck is it doing? Avery, another thing for you to go chase.
Okay.
It says 0 items and finished.
Okay, so we don't have this function. So how about we, since Ian has a one-line version of it, maybe he could put it in.
Okay.
And I have no idea what this is. I mean, this is no doubt amusing, but I have no idea what it is. Okay, I'm not sure I've seen this before in some way. I mean, that's kind of interesting, actually. Is this easy to compute what the nth term should be?
I don't remember. I'll take a look.
Okay, it seems like nobody is awake today. I'm not. Okay, so with respect to these agent-based models and hard sphere models, presumably what we want to do is define something which is analogous to the way that multi-way systems work, where you're basically saying you've got these, you have, okay, so it's kind of like event-based. Well, actually, we could just add a section here about quotes agent-based, aka event-based models. Okay, where basically what's going to happen is the confusing part is what we've already got is various functions that take, an A and a B that are both pattern objects, and say, let's say they give a C and a D, and then we are doing on a set of elements, these are subset replacements. Does that make sense? Anybody understand?
What is the connection between that and agent-based modeling?
Because it's saying if you take, a fox and a rabbit, A is a fox, B is a rabbit. Anywhere in the system, a fox and a rabbit combine for the fox to eat the rabbit or something. That's an event, right? So it's saying, given that there is a pattern of 2 elements, let's say, then there's an event that combines those 2 elements and gives you something different. That's the idea. Now,
sure. I mean, in general, just a function needs to run when an event happens, right? If you've registered that I care when foxes meet rabbits or when foxes are within radius whatever of rabbits, run this function when that happens, and that function presumably, does whatever it does.
Exactly. So the only thing it's sort of interesting, I hadn't really realized this before, but in our generic token event graph formalism and so on, we're just saying there is an arbitrary bucket you know, in a general token event graph, you know, it's like given a bucket of tokens of a certain form, here's an event that happens from them. Now, in a typical, you know, in these multi-way systems, it's like we look at all possible events that can happen from buckets of tokens that match the pattern. Am I making sense? Whereas in typical agent-based modeling, I assume that that's a Monte Carlo thing. Is that a fair assessment? Christopher, do you know?
Yeah, I think so. Yeah.
Right. So we've either got, you know, in general, we make a multi-way system from this. Or we probabilistically pick one path. Okay.
It could be difficult to make a multi-way system because some of the branching ratios could possibly be uncountable.
Both that and the fact that realistically, I mean, often often inside of these functions where, you know, okay, the fox is within radius of the rabbit and it has a n% chance of eating the rabbit, you know, people implement that stuff kind of naturally with like random choice.
Sure. No, I agree. The multi-way system is a rare case to want to do that. Mostly it's probabilistic.
Right. But I'm just saying the function, you know, I'm not like, we could design the whole function so that at each step you're expected to kind of give all the possible outcomes and probabilities associated with them. But that's hopeless. Yes.
I think it's hopeless. But I think so. I think this is going to end up being a, you know, it's going to essentially be a random, you know, what's actually going to be is a, you know, it's essentially going to be a random instance. Let's say we had sort of agent-based model.
Right. The only difference between it and something like a random instance is that when you have a random instance, it's because there's randomness like in the code that the system is running, if that makes sense, as opposed to being in the user's code. Right. I mean, if you run nest list, you can put something in the function that calls random real, and it will be non-deterministic. We don't call it random nest list.
I understand. I see what you're saying. Right. But just so I see. So you're saying the agent-based model has the randomness in it.
Right. I mean, it's the same as if you give an arbitrary function for a cellular automata, you can put randomness in it.
Yep. Okay, so hold on. So let's but the other thing that we okay, so one thing we need is okay, so motion, e.g. for a hard sphere gas, you know, how well do we model motion? Right, so one case is everything is on a grid. Everything is on a grid. And motion is just, e.g., move one square. Case two is it's genuine Newtonian motion, so to speak, or genuine, whatever you'd call it, Galilean motion. I don't know what.
Yeah, but there should be something in between 1 and 2. Like that has to do with the discrete approach to continuous calculus.
Perhaps. Okay. So you're saying, well, okay, genuine Galilean motion or a finite difference version of this. Okay, so what we're saying here is that in the end, see what's complicated here is that there are events. Okay, basically the point is that events can potentially give both, you know, a resulting x and x dot. How to enter that? How do we enter that? Oh, whatever. Does that make sense?
Yes, except for it doesn't, if you just say there's two things are going to happen, it doesn't seem to include the possibility of a branching factor.
Right. I think we're ignoring the branching for now. Like, I think that because again, the randomness will be inside of the functions. It will not be done by the framework.
Let's
But I
say,
think in general, right? I mean, in general, you're going to have to, from each event, you're going to have to return some whole spec, whether it's its own kind of object or whether it's an association or whatever, that basically gives all the actions that are supposed to happen. Because there's a whole set of, oh, kill this agent or create a new agent or move this direction or move to this position, et cetera, change your color to blue. I mean, there's a whole list of kinds of general things you might want to do. We're going to have some, object for representing them or something.
okay, but there's one thing which is the state of the system. And then the state of the system has, I mean, basically there's a global state. And then what's going to happen is that there's a function that says how to pick up parts of that global state. Picks up parts of the global state, modifies them, and replaces them. Right? I think that's the basic operation.
Sure. I mean, I think that there are going to be many functions though, because you're going to, I mean, right. For example, you might want something that, okay, it modifies the global state. It, you're modeling your foxes and your rabbits, and at every step you want to randomly spawn carrots, everywhere, right? Because the carrots are growing. But then you also want functions that have access probably to the global state, but also to certain kind of event-specific local state. So something like, oh, anytime a rabbit encounters a carrot, run this event, and then you want to be given the rabbit and the carrot, and then you want to be able to tell it something about, modifying this local situation, like kill the carrot and make the rabbit, more powerful or something.
So are the carrots agents?
Probably, yeah.
And what about the sticks? Are the sticks agents?
What sticks?
Everything is an agent. It's an agent-based model.
No, but I mean, the issue is you've got a big list. Okay. The basic point is you've got a big list of agents. And you're told how different agents combine to make other agents.
Not really. I know where you're trying to go with that, but I think not really. There are some models that are of that form, but there are lots that aren't.
Okay, well, there are models where you have a big bang all the time, where you go, nothing goes to carrots.
I mean, I think in practice, it's just going to be that there's going to be a list of agents, and the agents are going to have, the agents are going to basically be arbitrary objects. They're probably going to be associations with a bunch of properties like, how well fed is the rabbit kind of thing.
Yep.
And then there's also going to be a bunch of framework properties that they have, which are things like their position, et cetera. And the reason why that's important to be in the framework is that presumably we want to be able to have things like, you want to be able to specify the boundary conditions and stuff like that in a general way in the framework. And so then it would manage moving things around and so on.
Right. The point is that, for example, the sort of motion is sort of a built-in thing. The idea of space is a built-in thing, but little else is built in. I mean, the idea of the concept of space.
That the concept of space can probably be built into the update function, whatever the update function is.
Well, no, this is the point, that there'll be many functions that will happen at all sorts of different events. I mean, there'll probably be some that happen at every step regardless, and there'll be others that are event specific. And then each of these functions will return things about, move my agent this many squares this way. And then the framework is in charge of managing that and knowing how boundaries work and stuff like that.
Right, but if you take the extreme case of a hard sphere gas, where the agents do nothing other than, but then they have to compute when their next event is. That's the non-trivial thing.
Well, no, I mean, I mean, this would be a bad way of implementing a hard sphere gas model. But I think basically what you do is you'd have your agents, you'd say at every step, you know, apply this function to the agent. And the function is look at your velocity and move that direction.
Okay,
and
so
then you
you're
have an
saying
event that says if two agents hit each other or within some radius of each other, then compute new velocities.
Okay,
Yeah,
so you're
that's
proposing
not the that
step-based.
is not the event chain algorithm. That's more like what we have presently.
Right. I mean that's an algorithm that will get the wrong answer when they're, you know, when it gets very crowded. There'll be weird singularities. There'll be weird, you know, overlapping nonsense. But you know, right. That's the zeroth way to do it. And if you had infinitely small steps, then you'd basically be okay.
Right. But my point is that for the function we're trying to implement, arguably we should just try to, okay, then we're actually breaking these apart. The hard sphere case is just a separate problem from the agent case.
Definitely. I'm just saying it's right. You could do it as an agent-based model, but it's in the same way that with the n-body simulation, you know, self-gravitating gases, it's just there are much better algorithms for doing it more accurately without having a bajillion, you know, infinitesimal step size and so on.
All right, okay.
It's a one-off.
Okay, so now the next question is n-body simulation, the existing function we have. Can we put, from a design point of view, can we put hard sphere gases into it?
Well, I mean, maybe we should talk about systems that are having continuous events versus discrete events. Because the event chain thing is just saying, okay, we can write down a list of actions to take on the state space. And, you know, for the hard sphere gas, we kind of know what's going to happen. There will be propagation events interspersed with collision events, but we never need a time step because we can just keep solving the equations of motion.
Exactly. But whereas for an n-body, for a gravitational n-body problem, you never escape gravity.
The events are happening instantaneously all the time.
Right. But what I'm saying,
I mean, presumably, maybe somewhere in this picture of space-time, there are gravitons flying around.
Yeah. But we're not dealing with that level. We're just dealing with the modeling at the level that people think of modeling, you know, inverse square law and so on. Right. That's a whole different thing. I mean, yes, you know, the thing that, for example, Jonathan has been building for discrete gravity simulation does that type of thing. Okay, even more extreme than that type of thing. But the question that I'm asking is, if we were to just say, right now we have this notion of, you know, inverse square, harmonic, Newtonian, Coulomb, is there any reason we can't add hard sphere to this? And the algorithm will be different, right, for that case.
We probably wouldn't have a very good output of it because we don't have, one could probably shoehorn it in an appropriate interpolating function, but it's not our natural one.
Yeah, I mean, maybe what Michael is
hold on. I want to think about that for a second, okay? What about interpolation order 0 or interpolation order? You're saying that
1, yeah.
1.
No, I'm not speaking about interpolation order. Literally, the interpolating function object.
But what's wrong with it? If the sphere,
there's nothing wrong with it, but the one that comes from ND source has certain ideas about smoothness that are not fulfilled.
But why isn't an interpolation order 1, which specifically isn't smooth?
I mean, it doesn't have to come from ND solve.
Right.
So I think it will be a linear interpolating function, which would, it seems to me, do the right thing, because it would be between collisions, it would just be kind of linearly changing, I think. Well, that's a question. I mean, that's a question that somebody needs to work out, is will interpolation order 1, I mean, Brad, this is something, since you understand the n-body thing now,
Yeah,
Perhaps you
but-
could answer that question.
I mean, my perspective on this is that like an iterator based code that is taking time steps is going to have one type of output, and the event chain thing is going to have a different type of output. And what you would be asking for within body simulation would be more like the time step output. So if you do any
Why?
interpolation at
Why?
all, you've
Yeah.
already destroyed the natural output.
No, I
structure.
think we have a misunderstanding. If you scroll down a little bit on the right notebook, Stephen, like
Yep.
the internals of this n-body simulation data would be totally different for event chain based result than for an ND-solve result, is all what I'm saying. It could format the same summary box, but what's inside would be a totally different thing.
Which would be fine. And then the plot of that thing would be something that you get from an order one interpolating function.
This is a technicality, yes.
Right, but so what you're saying, Michael, is that inside n-body simulation data could be an event chain.
Or the result of an event chain.
Fine. Right. I
Yeah,
think it's
but
fine.
what would the output look like?
What the output is right here. This
It
is
is like a summary
just a
box.
blob.
Oh, okay.
All the information is invisibly inside.
Right. And the only thing you get to do is to ask questions about it, like what is its position? Right. So what this would be is packaging up. I mean, we could do this even right now with our existing algorithm for n-body simulation, which isn't the best, for hard sphere simulation, which is not the best one. I'm asking the question, with this design, right, could we have something which basically says here, this, instead of this, just says, hard sphere or something, right? Is there anything wrong with that?
If we assume fully elastic, smooth surface, yes. I mean, there are inelastic hard spheres. There are,
of course,
rough spheres. There are many kinds of hard spheres.
I understand, but the generic case, I mean, just like we don't have to have, we could have a relativistic correction to the Newtonian potential, but we don't. I mean, you can specify it, but that's I mean, so, the next question is, just like you can have an arbitrary potential there for the, named laws there, could we have an arbitrary thing that plugs into the event system? Possibly, yes.
Well, I think that's the way to get around this issue with having multiple collisions, actually. Because if you allow it to be user specified, then the user can say what they want to do when they get to multiple collisions.
Yeah, okay.
But the other issue was, do we need a message when there are multiple collisions?
I think the multiple, for practical application, the multiple collision is not really a relevant case, I would say.
Yeah, I don't think so either. But when we were doing the work for the upcoming blog, that we saw it all the time.
Right, but that's
this is one of these. I mean, there's also right. There's the issue of when you have high enough density, you end up getting just weird stuff, right? I mean, like I was going to mention, I mean, because we're talking about n-body simulation and collisions and stuff. I mean, another feature that might be nice that's vaguely related is having a collisions version of the self-gravitating thing. But the problem is again, like you often end up with, if you end up with a big clump of self-gravitating colliding things, you end up getting weird little singularities that make everything explode every so often and so on. It's kind of hard to solve those.
Right. Well, I mean, okay, look, the paths that we seem to be on are, can we parameterize the hard sphere thing if we make an event, an event list version of that? Can we we can put in the hard sphere case, the pure elastic hard spheres, which is the most useful case. And we could do that with our existing code.
Well, does the existing code have good enough precision handling?
No, it does not. The existing code is no good for that. However, as a way to understand the design and to get something rather than nothing, it's better than nothing.
And Stephen, what would it do? It would do machine precision or it
Yes.
would, okay.
Yes, it will do crummy machine precision, and it will get it right for some number of collisions, and then it will blow up. But it will do it, in other words, for many purposes, that's perfectly sufficient. If you really want to know exactly what given hard spheres will do, well, good luck preparing the initial state to 300-digit precision. Right? It's one of these things where just like it's all unrealistic.
Yeah.
So I mean, but it is very useful to have even approximate hard spheres. They show up in just all kinds of models.
Yeah.
And so that's what we should do, is take even our existing WFR code and just put it in, packaging it in this way. Now, what we'll discover is that some of the things that we have in the WFR code for hard spheres, like causal graphs and things, we don't have here because we never needed that. It doesn't make any sense to have a causal graph for an inverse square law. Does that make sense? Yes. No, maybe.
Yeah, it makes sense, but also the causal graphs can be obtained by just transforming whatever the output data is.
Fine. I mean, that may be a specialized thing, only of interest to us. But, for the agent-based models thing, there is presumably a causal graph of relevance because there are discrete events and they affect each other, presumably. I mean, presumably we can draw that causal graph for what it's worth. But it seems to me like, go ahead.
It may take a little more thought about whether the events are instantaneous events or if they're like discrete time events.
Right. Well, this one has instantaneous events, but it's in continuous time, whereas Christopher is saying that for most of the agent-based models people do, they're in discrete time. Is that a fair statement?
Yeah, I think so.
Yeah, because it's going to take some amount of time for the rabbit to eat the carrot.
Well, they're basically cellular automaton-ish like models, but they happen to be done with agents rather than where you're specifying if the local environment is this, then do this. Whereas in a cellular automaton case, in other words, the default of do nothing is much more common in an agent-based model than it is in a cellular automaton.
Well, I think it's also just that basically you get yourself into a whole lot of complication if you allow for continuous time, and most of these agent-based models are very approximate anyway.
Right. But so then what we need here is a way of representing, just like we have in cellular automaton. We just need a way to specify this stuff where the whole state of the system, the global state, is specified by some list of associations, probably. Let's say the state of each agent is an association. The global state is a list of associations. The events take, let's say, pairs of associations or individual associations, take lists of associations that match certain patterns and transform them. Is that a fair statement?
Yes, except for transform them, I think that you probably don't want to actually return modified versions of them. You probably want to be able to return something that sort of specifies what they're all doing, and the framework will actually mutate them. Because again, if you want to say something like this agent is moving up and to the left, you want the framework to manage the movement so that it can handle boundary conditions, etc.
Yeah, I mean, I might be agreeing with Christopher on this, that there's an overarching framework, I guess, and it'll maybe the framework has the initiative, and then it finds out an event is supposed to happen, so it passes down to an event handler, and then once the event is resolved, it goes back to the framework, which then looks for the next event.
I think that's fine.
Yes.
I think that's fine. Right. So there's a bunch of associations that look like this. And then all that's going to happen is there's an action function, so to speak. So that let's say it's agent-based model, agent-based, well, I don't want to call it model, agent-based simulation. Okay, which takes a set of rules and a state and a number of steps.
And those rules are kind of like it's an association or something where you're giving sort of event specs arrow functions to apply, where the event specs might be something like, 2 agents are within this distance from each other or something like that.
Event spec.
And somehow you want to be able to specify things also like 2 rabbits are within this distance from each other.
Well, I
or
mean,
carrots and so on.
Right. So this is a type rabbit.
Right. But again, by the way, I'm guessing position should be kind of outside of that association, because you should have this outer association that's sort of the framework one, and then you should have the general properties.
Well, I'm not sure that's right, because I think that there may be things that autonomous
only the framework will really be modifying
that run before the quotes programmer events, perhaps. Because I think it's useful to have this association where you can pick up, oh, I want to look at these positions. If the thing is near the lake or something, do this.
No, of course you should have access to the positions. This is sort of a pedantic point that arguably the structure of the association should just be that some of the keys are in some catch-all field like properties, arrow, and then some association. And that those would be all the sort of, programmer's keys, and that separately they're the framework's keys.
We should look at this. I need to go to a different thing. Another live stream, actually. Actually, I believe we're making progress with this. We should try and nail this. This seems to me, once it has a design, I just don't think it's that hard to implement.
Yeah, I mean, I think they'll end up being a lot of different cases for like I think the thing to do is to survey some agent-based models that are out there, and then we'll find out that there are 75 different kinds of events that they use, and it'll be a matter of getting those.
Right. All right, we should wrap up here. Thanks all, and yeah, have happy holidays, and see you all soon. I'm not actually, maybe we even have some. I keep on thinking that this week is about to be. No, I think this is our last live stream, design review live stream, at least this week. So okay, thanks all. See you all soon.
Bye.
Bye.